Hello, everyone. Welcome to the pre-lab video for the Electrochemistry 1220 lab. All right, so this week in lab, we have two hazards to consider. We'll be working with strong acids, which can damage yourself and your belongings. And then we'll also be working with heavy metals that are both chronically and acutely toxic. Right? And so protect yourself by wearing gloves and goggles throughout lab and cleaning your hands thoroughly once you leave. All right, so on to the description of what you'll be doing this week. So the goal of this week's lab is to use chemical reactions, to use chemistry to light an LED. Right? And so whenever we're doing a reaction, we're proceeding from reactants to products, and we're releasing energy in the process. Right? And so during today's lab, we're going to try to capture that energy and use it to do something. More specifically, we're going to use it to get light to come out of an LED. Right? So the reactions that we'll be using in order to light this LED are electrochemical reactions that involve the transfer of electrons. Okay. Now, our mnemonic for electrochemistry is, of course, oil rig, where oxidation is a process that involves losing electrons, and reduction is a process that involves gaining electrons. And so throughout lab today, you'll be working with different metals, both in their cation form and in their solid form. Right, so one example of an electrochemical reaction would be conversion of copper 2+ in aqueous solution, having this copper pick up 2 electrons to form solid copper. Now, the willingness of copper to pick up these electrons is described by a parameter called the reduction potential, E0. And for this half reaction, any reaction where the electrons are still included as a product or reactant is a half reaction. The reduction potential for this half reaction is 0.2 volts. So you can see here in this reaction going from reactants to products, copper gains 2 electrons. And so this is a reduction reaction. Another reduction reaction could be the reduction of aqueous silver 1 to solid silver. And the reduction potential of this half reaction is 0.8 volts. Okay. So in this lab today, you'll be putting metal ions onto solid metals and seeing whether or not they react. And the thing that determines whether or not these things react is which of these reduction half reactions has the larger reduction potential. So in this case, the reduction potential of silver, 0.8 volts, is greater than the reduction potential of copper. So we would say that silver is stronger. And so if silver 1 and copper 2 get a chance to compete for electrons coming in, silver is going to win. And so what this means is that if you have a system where this happens, right, since silver wins, it gets to be reduced. And since copper loses, it is going to lose its electrons. So silver gets to proceed as a reduction. And copper is forced to proceed through oxidation. Copper solid to copper 2+ plus 2 electrons. So to get to our net reaction, we need to add these together. And to balance, we'll have to double the top reaction. So our net reaction is that 2 silver 1 cations is copper, This is a 2-electron transfer. Gives us 2 solid silvers and a copper 2 cation. So this is our net reaction. And so you'll be doing these kinds of reactions in lab today by putting different combinations of metal cations onto different metals. So if you were to take a strip of copper metal, put a drop of solution on it that contained silver plus, this reaction would go ahead and it would proceed. And once you dried off your strip of metal, you'd be left with a strip of solid copper that had a little circle of silver deposited onto it. So in part 1 of the lab, you'll be using this approach to doing redox reactions where you're just putting drops of solution onto strips of metal. Then in the second half of the lab, you'll be using something called a galvanic cell. All right, so here is a diagram of a galvanic cell. So in a galvanic cell, you have solid metal, in this case silver, in contact with a solution of silver cations. And on the other side of the galvanic cell, you have solid copper in contact with copper 2 ions. And so here are the 2 reduction potentials for each of these half reactions. And as we just discussed, since silver has the larger reduction potential, it wins in the competition for electrons, and electrons will flow from this side of the galvanic cell, from the copper side, through the wire connecting the 2 sides and over to silver. And we will reduce silver cations to get additional solid silver metal. Because copper has the lower reduction potential, it is being oxidized. And so solid copper loses electrons to form additional metal cation in solution. So to calculate what voltage, right, what amount of energy we have as electrons move across this wire, we calculate that voltage as the potential for the net reaction, which is the potential of the reduction half reaction minus the 0.2 volts of the oxidation half reaction. Reducing silver can give us 0.8 volts, but we have to give back 0.2 in order to oxidize the copper. And so the total voltage that we expect to see across this cell is 0.6 volts. Thank you, and I will see you all in lab this week.